In Chapter 5, Section 2, as we're pursuing our state standards, we need to focus on some zero and negative exponents. So we're still working on standard number 7, and we'll come back to that in a moment. But for our zero and negative exponents, if n is a positive integer and a is not equal to 0, any number raised to the 0 power is equal to 1. So we had some laws of exponents yesterday in our previous lesson. We need to learn some more today. And this comes from the fact that if you take one of the laws of exponents we learned yesterday, if you are dividing and the bases are the same, you're going to keep the base and subtract the exponents, numerator minus denominator. If numerator and denominator are the same, x minus x is 0, we get a to the 0 power. But realize that if I have the same quantity in the numerator and denominator, anything divided by itself is going to be equal to 1. So therefore a to the 0 power is equal to 1. Negative exponents. A negative exponent, the symbol here means not that the base is negative. It means to take the reciprocal of the base. That's what the symbol means when you have a negative exponent. So any base raised to any negative power is 1 over that base raised to that same power, but now it's positive because we performed the operation that was expected here, and that's taking the reciprocal of the base. So a to the negative n is 1 over a to the n. And it's important that we memorize these laws each day as we learn them. Now, one little fine print here. We said anything to the 0 power is 1. There is one slight problem with that. You cannot take 0 to the 0 power. That would be undefined. Why is that? Well, that would be like saying 0 to the x power divided by 0 to the x power, and you couldn't have 0 in the denominator to begin with. That would be undefined. So therefore, 0 to the 0 power is undefined as well. Alright, with the exponents that we have previously learned and the laws of exponents that we introduced today, let's practice them in these numerical examples. 5 to the negative third power. That negative exponent means take the reciprocal. So it's 1 over 5, and now it's to the positive third power. And if we simplify that, 5 times 5 is 25, times 5 is 125, and that's in our list of perfect cubes that you were supposed to memorize also. 5 cubed is 125. Alright, in this example, it's very important that we know what the exponent is being applied to and what it is not. There are not parentheses around negative 4x. So it's important to know that we have negative 4x, and that is being multiplied by x to the negative third power. This third power, the negative third power, is only being applied to the x, not to the 4 or to the negative 1 in front of it. So what that means is we're going to have negative 4, but then we need to take the reciprocal of x, and that's going to give us negative 4 times 1 over x to the positive third power. 4 is really negative 4 over 1. So multiply the numerators, we get negative 4. Multiply the denominators, we get x to the third power. So negative 4 over x to the third is our solution. In this next example, 5 to the negative 1 power times x to the 0 power times y to the negative 5th power. So that would say take the reciprocal of 5, 1 over 5 to the first power. Anything to the 0 power is 1. And this says take the reciprocal, so that's 1 over y to the positive 5th power. When we multiply all our numerators, 1 times 1 times 1, we get 1. Multiply our denominators, 5 times 1 times y to the 5th is 5y to the 5th in the denominator of example 1c. Alright, let's look at example 1d. Now we have parentheses around this 4 times x, and the entire 4x monomial is being raised to the negative third power. So in this example, I need to take the reciprocal of 1 over the quantity 4x, and now we're raising that quantity to the positive third power. So when we do that, 4 to the third power, 4 times 4 is 16, times another 4 is 64, and x to the first power quantity cubed is x to the third power. So my answer is 1 over 64, x to the third. Alright, let's look at example 2 here. It says write in simplest form without negative or zero exponents. So we want to use those properties not only forwards but backwards as well. So write them without negative exponents. Well, first I would say you're multiplying here. That's a multiplication sign, not an x. And the bases are the same. They're 10. So we're going to keep the 10 and not change it. We're going to add the exponents. Negative 3 plus negative 4 is negative 7. So I will rewrite this as 1 over 10 to the positive 7th power. And I double check. There's no negative exponents. There's no zero exponents. Next example, to rewrite it without negative or zero exponents, which is what we would call simplified form. I've got the quantity negative 2, x to the negative third, all of that raised to the negative 2 power. We might want to break this down and say, well, that's negative 2 to the negative 2 power. And that's x to the negative third to the negative 2 power. Now this is not the only way to start this problem. I could take everything in parentheses and put 1 over that and then make that a positive second power. There's many more ways to do this problem than this way. I just chose to start it out this particular way. So negative 2 to the negative 2 power, x to the negative third to the negative 2 power. As we continue, that's going to be 1 over negative 2 to the positive second power, as this negative exponent says take the reciprocal. So it's 1 over negative 2, and now it's quantity to the positive 2 power. And here, when you have a base raised to a power, and that in turn is raised to another power, whether they're positive or negative, the law of exponents still holds. You multiply them. So negative 3 times negative 2 is positive 6. So I have x to the 6th over 1 times 1 over negative 2 quantity squared. But let's keep simplifying that. That gives us x to the 6th in the numerator. And negative 2 times negative 2 is positive 4 times 1, which is positive 4 in the denominator of example 2b. All right, let's continue. We have a monomial divided by a monomial in 2c. Let's begin by simplifying. 2 to the 0 power is 1, and 3 is just 3 in the denominator. Now when I'm dividing, and the bases are the same, which they are, they're x, I'm going to keep the base and subtract the exponents, numerator minus denominator, so that's negative 2 minus negative 3 power. And then I'm dividing still, and the bases are the same, so I'm going to keep the y and subtract the exponents. Don't forget there's an invisible 1 up here. 1 minus negative 2. And as we simplify that, don't forget that you're subtracting negatives are the same as adding positives. So 3 plus negative 2 is 1, and that's x to the first power. 1 plus 2 is 3, so that's y to the third power. And 3 is in the denominator, x to the first, y to the third is in the numerator. All right, another example, we have a fraction raised to the negative 2 power. Several ways to start this one. I might start by taking the reciprocal of the base and make that 5/3 instead of 3/5. Now we're going to square that. So 5 times 5 is 25. 3 times 3 is 9. 25/9 is my answer. And our last example is to rewrite without using fractions. So here's where we're truly going backwards. I have 3x squared over 4y cubed. I don't want a fraction, so I'll have to use some negative exponents. So the 3x squared is already in the numerator. That doesn't need to have any negative exponents. What needs negative exponents is the portion that's in the denominator. So I have 1 over 4 y to the third. If I make those negative exponents and still keep my 3x squared, 1 over 4 is going to become 4 to the negative 1 power. Because remember, when you have a base raised to a negative exponent, that means take the reciprocal. So to go backwards, if we have 1 over 4, that's 4 to the negative 1 power. 1 over y to the third is y to the negative third power. And if we simplify that, we have our answer. We have 3 times 4 to the negative first power times x squared times y to the negative third power. So again, before we can continue with state standard number 7, we have to master our laws of exponents. including zero and negative exponents, which we covered today.